Now the first question here to do with titrations, question 4a, shows a titration of a weak acid starting here. It's ethanoic acid, and it's been titrated with a strong base, 0.1 mole sodium hydroxide, an equivalence point around 20 mils. But the first question actually relates to a second titration. And we're asked to calculate the pH of the initial weak acid solution. We're given some information. We're given the pKa. We're given a concentration of the weak acid, which is 0.2. And from that we should be able to do some calculations. So when we follow through and do that, convert the pKa into a Ka and use that, we get a pH of 4.69. And also, however, asked to calculate the pH at equivalence point, so we just have to go a little bit further for that one. Now, in the equivalence point, obviously the weak acid is now turned into a weak base, so instead of using the Ka, we used to use the Kb equals OH minus hydroxide ions squared over the concentration of the weak base. We need to convert Ka into Kb, which we just do by dividing 1 times 10 to the negative 14, I should put that there, by 2.04 times 10 to the negative 9, or Ka. And that will give us, this is the answer for Kb. But the concentration of the weak base here, this has been altered because the weak acid turns into the weak base. It was 0.2, but we've added to that 10 mils. We've got a total volume of 10 plus the 20 mils from equivalence point. That gives a total volume of 30, so that's the actual concentration. So we go 4.9 times 10 to the negative 6 times by 0.0667, and take the square root of that, we'll get the hydroxide ion concentration. So I'll do that now. So what I should have really said is, obviously we're calculating the hydroxide ion concentration, so we need to do a conversion to make sure we get that pH correct and don't make a simple error there. So that's 10.75, and obviously you'd expect the pH at equivalence point to be greater than 7 because we're now dealing with a base. Okay, so that's the first part of the question done.